Good afternoon. One of the risks speaking at 4 o'clock is that maybe everything that needs to be said has been said, but hopefully that won't be the case today. I want to talk to you a little bit about a part of this solving the puzzle, which is the theme of SAFE this year, and how we fit into that equation. We've heard today from miners, battery producers, battery recyclers, lots of different areas in the value chain. We haven't heard too much about the mineral processing, and that's where we come into the picture here, and I'd like to talk to you about that today. Not only how do we do the mineral processing, but how can we help our mining customers who are working hard every day to do that more sustainably. We've heard today from many of the speakers about the increased demand for minerals, so I don't want to belabor this point, but from a 2021 baseline out until 2030, we expect the use of electric vehicles to grow 7 times, maybe even greater. Every one of these vehicles using 6 times the minerals that's required in a conventional ICE vehicle. If we talk about wind turbines used for energy production, over 4 tons of copper used in every wind turbine, over a ton of rare earth elements used in every wind turbine. So these are big numbers when we look at the tens of thousands of wind turbines that are being produced and deployed around the world. Earlier it was asked, is copper a critical mineral? I'm not sure if it's critical, but it's certainly very important. We've been using copper as society for about 10,000 years, so it's not a new thing. For about 5,000 years, it was the only metal that was used. And then additional metals were discovered with their own special purposes and uses to make society more effective. But copper has been around for a long time. It's critically important to allowing us to achieve the electrification of society and meet the goals that we have out there for reducing CO2 emissions. I'd like to talk a little bit about something that hasn't been talked about today. After we mine the minerals out of the ground, copper in this case, a lot of processing has to take place before you actually get the copper. We've heard from several mining customers today, one that's very big in copper, and how they go about doing the mining. When we think of mining, we often think of a large open pit, large shovels, extraction equipment. It's not something we do in FL Smith. We start with the primary crushing step. So when you get these large pieces of ore that can be 1 meter in diameter, more than 3 feet in diameter, they have to get broken down through successive steps of crushing and grinding to get down to 150 microns, what we would typically think of as dust. So a lot of energy goes into that process, as I'll talk about here. The crushing step, the grinding step. Grinding is performed with very large SAG and ball mills, which can be up to 30 feet in diameter, tons of ore rotating in them with large steel balls. This is the way you break down the material and get to that small particle size, which then goes to the next step, which is flotation. Flotation is where we add bubbles, certain chemicals to the mixture, floats the valuable minerals to the surface where that froth can be skimmed off and the valuable minerals recovered. And then we go through the concentration of the valuable minerals and the thickeners, concentrate filters. And then finally, we have to deal with the slurry mix at the end, which is referred to as tailings. This needs to be stored in a responsible manner. Many people have heard about the issues with tailing storage facilities and some of the challenges there. I'll talk about that a little bit more later. But these are all the challenges that our mining customers have to deal with, getting the minerals not only out of the ground, but to a process state where they can be used. And we're talking about a lot of material here. The largest copper mine in the U.S., the Morenci mine in Arizona, operated by Freeport-McMoRan, using over 100,000 metric tons of ore per day being processed there through the 2 concentrator lines. So huge amounts of material being used on the copper side of the business. We're also very active in zinc, lead, gold, lithium, the other rare earth elements. These are much smaller volumes of material to deal with. So keep that in mind. Copper is important. Not only we need to have the mines to get it out, we need to have efficient, effective means to process that material. It uses a lot of energy, uses a lot of water. And that's why we want to help our mining customers do this more sustainably. So just CO2 emissions, the circuit that I just showed you, that simplified flow sheet, doesn't emit any CO2. There's nothing going on there that's emitting CO2. The extraction trucks that are typically diesel electric, our mining customers are doing a lot to try to electrify those. But a lot of electricity is used. As I mentioned earlier, the crushing and the grinding of the ore uses 2 to 3% of global electricity, of all electricity produced. That's a huge amount. One large SAG mill at a mine site can consume 20 to 25 megawatts of power. So a huge power draw there. If we can do that more efficiently, that's going to help us be more sustainable in mining. Also very water intensive. Many of these mines are in areas that have extreme water stress or high water stress. We heard earlier from Teck how they had to build a desalination plant in Chile to pump seawater up to the mine site to be used. Very expensive. Avoids the use of the local fresh water, but requires a lot of energy, a lot of cost. If we can help our mining customers do the mineral processing with less water, recycle that water, they're going to be more sustainable, more economical. And then finally, something which isn't talked about too much outside of the industry in copper, the ore grades of copper reserves are going down around the world. To put it another way, the easy copper is already out of the ground. We've been doing that for thousands of years. Not a lot of new copper sites have been developed in the last few decades, and that was talked about earlier as well. So the ore grade is declining, which means you have to produce more and more ore, excavate more and more ore out of the ground, process more and more ore to get the same amount of copper against a backdrop where there's a significant increase in demand for copper. So we're a Danish company. We're headquartered in Copenhagen. We've been around for about 140 years. Most of that time period making cement plants, more recently been involved in mining over the last several decades. But we've got about 1,000 employees here in the U.S., in Salt Lake City, in Tucson, Arizona, in Allentown, Pennsylvania. Here we have our engineering, product, technology development, which is supporting our global mining customers. 5 years ago, we launched a program we call Mission Zero. And this is our program to help our cement and mining customers achieve zero emissions by 2030, to achieve zero wasted energy and zero water waste. So it's our part of trying to help our mining and cement customers meet their ESG goals. This is a little more complicated, although not a full flow sheet, but a little more complicated view of what actually happens in the mineral processing circuit from what you saw earlier. And there's 3 areas here that I just wanted to touch on that we're working on. First of all, to say there are technologies available today that we have developed and we are deploying in pilot scale and in greater operational scale at some mines around the world. But the mining industry is very conservative, and there's reason for that. They're building a mine processing circuit. It's going to be operating 30, 40 years. They're not looking for the next version of technology every 6 months. They don't want an upgrade every 6 months. They want something that's going to be reliable, be there for a long time, and deliver. So we're looking for incremental ways we can improve their operational performance in the mineral processing circuit. One way is through new grinding technologies, which allows us to utilize dry grinding and air classification to avoid as much water use as necessary with conventional SAG ball mill circuits. We're also have developed technologies for new flotation techniques that allow you to perform flotation faster, to have a higher recovery, which helps get the copper and other minerals recovered with less energy. And also coarse flotation, which allows you to float larger particles. So I talked earlier about all of the energy that goes into breaking down the ore to this fine dust that you then have to float to recover the minerals. If you can float larger size particles, you're going to be able to use less energy. And then finally, dealing with the tailings issue, which is how do you avoid having large tailing dams, large tailing storage facilities that take up a lot of land and may pose a risk. I commend South 32. They talked earlier about their Hermosa project. They've got a booth over here next door. They've decided to use dry stack tailings. So when you get to the tailings at the end of the process here, you can use our filter press technology. You can extract the water, recover, reuse up to 90% of the process water. Now you're just depositing paste-thickened tailings or even drier tailings, eliminating some of the size and some of the risk associated with that. If we do talk about lithium, lithium comes from several places. Comes from hard rock spodumene, comes from brine evaporation pools, comes from geothermal wells, also clays in Nevada. There's several projects right now that are moving forward in Nevada for recovery of lithium from clays. We're working with all of these technologies, working with our mining customers in our Mineral Testing Research Center in Salt Lake City. We are doing testing on the ore samples, helping them optimize their circuit so that they can have the most efficient processing of the lithium possible. And then finally, when we say processing lithium in the most efficient way, to go from lithium carbonate to lithium hydroxide, which is used in the higher density, higher performing EV batteries, a byproduct of that is calcium carbonate. With our multiple hearth furnace, we can help our clients recover more of the valuable lithium from the calcium carbonate and also recycle some of the lime. We piloted this technology last year in Japan, and we have a follow-on installation that's going to be taking place this year in South Korea, where this lithium carbonate and lithium hydroxide processing takes place. So in summary, there are environmental impacts to mining. They can be reduced. We encourage our mining customers in the industry to consider these new technologies, take some risk in deploying them, help them reach their ESG goals, and move faster in that regard. There are barriers to deploying some of these. Getting new permits at mine sites can be a problem to deploy new technology. And then operational disruption concerns are there. These mines run 24/7, 365 days a year. They can't afford to have some disruption in their processing circuit. But some risk is needed to try some of these new technologies that are going to make a difference. They're not insurmountable barriers. Companies like ourselves, FL Smith and others, working with the industry to try to advance more sustainable mining. Thank you very much.